Delano is a agriculturally based community, rural community, where we are the majority of about 70 plus Latinos, about 20 Filipino community, and it's historically based from a railroad town by Chinese railroad workers, and it ended up going through a national spotlight where the farm worker movement started from here.
City of Delano is an ag-based community of about 50,000 people. And basically a lot of our jobs within the city are based on our ag.
When it comes to Delano, the Central Valley, water is our life. It feeds our community, it gives us jobs, it is the lifeblood of what is our future.
The City of Delano is a good test site for nitrate treatment technology because they do have issues with nitrate in the groundwater wells. And like many places in California and around the country, there's no good way to dispose of nitrate waste streams from the conventional nitrate treatment technologies. So it's a good fit for a technology that doesn't create a waste stream.
We've been struggling with water quality for years. We were under a compliance order for arsenic. Well 35 was part of this project.
During the 80s, when the nitrate became an issue, in order to get away from it, we drilled deeper wells. We sealed them down to about 800 feet, 900 feet, which got away from the nitrates. We're in the higher level, but the arsenic, it was below the MCL 50 parts per billion, but it was like in the 20s or 30s. So when the MCL changed for arsenic, we would have to either treat the wells that we had, or we'd have to drill new wells. Out of 14 wells we drilled, 5 had to be abandoned because we couldn't make viable wells. The other 9, 2 of those we're having to treat. So we're shooting about 50%.
The community is very aware that they are paying for quality water and they want to get it on time all the time. Nitrates going up and having to shut down that well was not going to be a pretty thing.
So nitrate comes from a number of sources, including farm usage around here, very much an agricultural area. That's the most common source for nitrates. We also can get it from septic tanks. The challenge is that it affects our populations in various ways in a negative way. And there's even new research showing that there's even greater effects on the wider population that aren't yet quite understood.
The main known health effect associated with nitrate is called blue baby syndrome. It's essentially a reduction in the oxygen carrying capacity of the blood. And this is a particular issue for infants where nitrate gets into the gut, can be converted to nitrite, and then literally the capacity for oxygen in their blood decreases. So you lose the ability to move oxygen throughout the body. Nitrate is one of, if not the most common groundwater contaminant across the United States. It's found all over the Midwest, the agricultural Midwest. We find it throughout California, the Pacific Northwest, it's in Texas, it's really all over the country. But you can see all the areas where there's a lot of agricultural activity, you see a lot of nitrate contamination. Biological treatment is really an old school concept of using naturally occurring bacteria that are already in the groundwater, letting them grow up into a biological reactor and using them to chew up the contaminant and convert that contaminant to a completely harmless end product.
You might call the nitrate to these organisms kind of like a Hershey bar. They're able to utilize the energy that comes from that, and that's how they grow. That's how they get the energy to grow.
MCL stands for maximum contaminant level. It's essentially the standard that the EPA sets for a particular contaminant in the groundwater.
This particular well has a nitrate treatment issue. It's now above the legal limit for nitrates in the groundwater, and so a treatment system has to be put in place in order for them to use this as a reliable source of groundwater for the drinking water system.
So this is the City of Delano well 35. This is about our 3rd generation biottta pilot. We have the raw water that's coming in, and you can see it's going to these break tanks. So once the water gets there, the pilot takes over. And there are basically 4 main components to these pilots. There's the unit processes, these tall columns right here, a feed pump here that takes water from the raw water break tank and pumps it through the system and to the unit processes. So So this is the first stage fixed bed bioreactor here, where all the nitrate gets reduced to nitrogen gas.
So this is the granular activated carbon that we use. As you can see, this is absolutely fresh activated carbon, so we're not inoculating bacteria before we put them inside the biota process. So we use bacteria that's already existing in the groundwater.
The water then passes, it can either go into the second column, which is a degas unit, or it can bypass that column altogether and go into the second stage aerobic biofilter, that third column right there, which is both sand and GAC. So the first component is the unit processes. The second main component of our biota pilots are the chemical feeds over here. You can see 5 tanks down below here that we keep full of like the food for the bacteria. These tanks are filled every few days or so, and then little peristaltic pumps feed those chemicals into different parts of the unit process.
So right now I'm making chemical stock for the chemical tanks that feed into the biota process. So you can see these are the peristaltic pumps, and we can automate so that they pump a certain speed, a certain dose into our biota process.
The third part of our pilots are the inline analyzers, which you see above the chemical feeds. We have our inline nitrate analyzer, dissolved oxygen meter, and then 2 turbidimeters here as well. Perhaps the most important is the brains. The fourth component, our PLC, which runs the system. It's very important that these systems are completely automated, so the system is programmed based on the operating set points that we've developed and honed over the years, and we can go in here, physically set those operating set points if we want, and download data and so forth right here on site, or this same human-machine interface right here, I can download onto my laptop wherever we are, wherever I happen to be, and look at that same screen and change operating parameters, download data, and things like that. This is the whole thing that makes the system go. There are 2 main reasons why the biota system is particularly green. One is that it converts contaminants to harmless byproducts. The second thing is that the biota system requires very, very low energy to operate. The O&M costs on this system tend to be very low. We want to be able to put these systems in, and then they just go. The California Division of Drinking Water is a group we've been working with for a long time. They've given us the conditional approval for the process, and we'll be permitting the full-scale system that goes right here at well 35.
This process has started for this particular installation about 2.5 years ago, where we went and approached the state of California as a new technology that could solve a widespread problem throughout the Central Valley here, as well as throughout California, and ultimately throughout the United States and the world.
I found out about the Prop 50 Chapter 6B grant money. It is specifically targeted for research projects to address a contaminant that is of widespread concern. And the City of Delano was very excited to partner with us in this opportunity.
Corollo has been an incredible partner with the city for the fact that we got to be the first site to be able to utilize their technology and their pioneering efforts, and even more, for it to be successful, I think it just speaks volume in regards to their initiative and wanting to making sure society is able to progress and Delano benefiting.
So the pilot testing showed that we can remove the nitrate from the groundwater very efficiently in short contact times. We used all those design criteria from that pilot study to build this full-scale system behind me.
There couldn't have been any better results. It looked fantastic, and so there's very little doubt going into a full scale when you have such good pilot work. Adage is an applications company. We bring technologies in the marketplace and apply them for communities, mostly in the groundwater industry for municipalities. And in the case of biota, it's a biological process that's been developed, and then we bring it to the marketplace. In the case of Delano here behind us, we have a number of sub-assemblies that were manufactured at Adage in Duluth, Georgia. And so what that does for us is it allows us to control the manufacturing process and then deliver components to the site that then get tied together. So we have one main degas skid in this case where that holds our process pipe, our valves. A lot of the moving parts are on that main skid. And then we have a water quality analyzer, chemical feed process, and our blower and backwash package. So once that's delivered then here to the site, a contractor will then pull together the vessels, the sub-assemblies that we provide, and it'll finally be tied together by Adage coming out and doing an integration. Our vessels are manufactured by a vessel manufacturer that specializes in steel and fabrication. That's all ran through Adage. We're the ones selecting the manufacturers. So you can come to Adage, come for, hey, this is our issue, and essentially then we deliver you a solution as far as from an equipment side. When you bring the vessels in and then you bring another skid in and try to pull all that together, essentially it fell kind of into place as if it was puzzle pieces made out to be. You know, design was done very, very smoothly. The overall project came together in a very short period of time. Anywhere from the design to the manufacturing to the installation to now the system startup, everything has been very smooth and operating successfully.
We've had a relationship with Corollo for years, so again, it went very, very efficient, I thought. The construction process went as well as any of our other projects that we've had, even though it's new technology. PCL has done a good job at not being overly burdensome on the community there.
The real baseline of the technology and the process at its core has been done throughout the United States and the world for decades and decades, just other applications. What we've tried to do here is take the basic concepts, see where there have been challenges in the ways that they've been applied in other treatment processes, and try and improve each of those areas, get over the hurdles that have caused the problems in other places. And that's why we've landed with this type of a system. And so what you see here is a relatively small system, but it's easily scalable and modular up to millions of gallons per day.
From the time that we went into manufacturing, I believe it was around 16 weeks from when we delivered the equipment to the site. And then from the time that equipment was delivered, it was about 5 to 6 months before the plant was fully constructed. Things came together very rapidly.
I think the goal here is to make the bench version of what we tested work in a conventional setting. It's really a great thing for Delano to be able to use a well that they put in where they couldn't before, and now they'll get the benefit of that water. Every plant is the same to operate, just depends on how big it is.
I work here maybe 24 hours a week. The only reason I really have to come out here to the site is to ensure that I perform my laboratory tests as the regulators require. There are 4 main duties that an operator must perform at a biota operation system. The first one is to calibrate the pumps and the analyzers to ensure that they're pumping and analyzing correctly. We need to pump chemical based on what the analyzer tells us. So those 2 components are critical to biota operation. The second operator duty would be to check and order new chemicals and materials as are required. And the third duty as an operator would be to maintain and keep the plant clean. And the fourth operator duty is to ensure that laboratory tests are performed as the state and regulators require.
So this is our programmable logic controller for the biota facility. This is the brain of the facility. So this controls all of our pumps, it controls all of our analyzers, our chemical feeders. So it's monitoring everything that's going on in the system and telling everything what to do. So this controls not only the brand new biota facility, but the original well facility as well.
This gives me total control over every aspect of the plant. We could see the results of all our analyzers. It's real time. We could also see how much chemical we have. Acetic acid, phosphoric acid, so you can see the tank levels. We have our hydrogen peroxide, our other hydrogen peroxide pump, coagulant. We have our PLC input-output.
And I think we've learned a lot just in the operations end of it. Engineering and operation are two different facets of what we do. So from the operations end of it, we've figured out some things that we may not need somewhere else, and some things that we may need to upgrade somewhere else.
Well, the education process that the grant will furnish is that there will be all the training that will be involved for our staff, plus there's going to be additional training for and classes for people that want to come in and look at the new technology.
The goal is for this to become a demonstration facility and an education center for nitrate, the problem of nitrate, the challenges of where it is throughout the state of California, and a new solution that can be applied throughout the Central Valley and other locations around the state and around the country.
You really want to turnkey operations. What the idea of this plant is you turn it on, it works, minimal supervision, minimal operator interface, and that's really the key to biottta.
Just like to welcome everyone on today's Nitrate Education Center on treatment facility at Well 35. Obviously, water is a precious resource, and just about 9 months ago, this well had to be shut down for the fact that that nitrate level ended up reaching a capacity that was not being able to be given to our people in Delano. But due to this new technology, this pioneering technology, we are taking the steps to hopefully make an example of what this could actually do for not only Delano, but the state of California and possibly across this nation.
There hasn't really been technology in the past that is as versatile as what Dr. Brown has put together here in this facility. It's truly a remarkable piece of technology.
I know working on this project a couple years ago when we talked not only about this well and some of the other wells, not just in the city of Delano, but even in the Central Valley, some of the things that we're always concerned about is the reoccurring nitrates and arsenic. And when I looked at this project and when we saw what Corolla was bringing to the table with the biottta system, it's really not just an investment in the community, but in this technology to see how well it's going to work, right? Because at the end of the day, I know for the mayor and the council and everyone in the community, they want safe drinking water.
To have this not only be a treatment facility for nitrate, to be an educational opportunity, to be able to bring people from the surrounding communities in and teach them about what this is and that it's not magic and that it does work and it's based in science and based in engineering and it can be applied at this scale, at larger scales. That's the next part of the magic that we want to help create and have happen and really solve this problem that we've been struggling with in California for so many decades without a solution like this that doesn't just take the nitrate and push it down to somebody else's problem as we concentrate it. We're destroying it in an environmentally sensitive way, environmentally sustainable way, and with very low energy doing it. So I'm just really excited to be here. We've been talking about this day for so many years, and thank you for coming and thank you for having us in Delano for all of this time. The Delano has been an unbelievable host for us to be able to come and play with some toys here for the last couple of years, and we hope to continue that relationship for a long time. Thank you.
The facility's been operating for a little over a week and a half now. The nitrate's coming in at about 10 milligrams per liter, right at the limit. Coming out of the system is less than 0.2 milligrams per liter, so we're getting complete nitrate reduction. We have some optimization of the post-treatment left, but right now everything is looking great in terms of the nitrate removal.
A lot of the challenges that we foresaw are not going to be challenges, for the process. So it's going to be simpler for the process. And with that, you have a product that has a higher quality standard because it's replicated. We're able to bring it to the marketplace faster, and you're going to see a lower cost as a result of that.
The fact that this was the first and only plant of its kind, and the fact that this technology to be able to implement it here in Delano, makes me feel proud in the sense that the community is seeing us to making sure we're providing a service. And not only providing a service, but we're looking out to the future. We're making sure that the people of Delano has something to look forward to, and that's clean drinking water. And if there's issues of nitrate, well, you know what? We found a solution.
When you're implementing a brand new technology, you always run into this issue of People want to go see a full-scale facility. They want to talk to the operators. They want to see it operating successfully. You need a full-scale track record. Up to this point, we've not been able to point to a particular facility, and so it's been a barrier to implementation of this technology. This facility is going to help us overcome that. It's really going to open up some doors toward implementation here in the Central Valley, across the state of California, across the United States, and really globally as well.